You are standing in the desert an hour before sunrise, and you are holding a shallow clay dish, and inside that dish, floating on top of a thin layer of water, there is ice. Real ice. Actual frozen water that you can crack with your finger and drop into a cup. The problem is that yesterday afternoon, in this exact spot, it was 50 degrees Celsius. That's 122 Fahrenheit. Hot enough to cook meat on a flat stone. There is no fridge, there is no freezer, there is no machine anywhere on Earth that can make ice, because that machine will not be invented for thousands of years. And yet here you are, in one of the hottest places humans have ever chosen to live, holding a piece of ice you made on purpose. So how? How does a civilization with no electricity, no compressors, no chemicals, no cold anything, sit in a furnace of a country and pull ice out of thin air? Because the Persians did exactly that, over 2,000 years ago. And they did it so well that some of the machines they built to do it are still standing in the Iranian desert today. And the answer is one of the most beautiful pieces of engineering the ancient world ever produced, and almost nobody has heard of it. Stay with me, because by the end of this, you'll understand a trick so clever that modern scientists only fully explained the physics of it in the last few decades. Let's start with why this even sounds impossible, because understanding the problem is the whole key to understanding how they beat it. Heat, cold, temperature, all of it comes down to one simple idea. Everything is either gaining heat or losing it, all the time, and whatever is winning that race decides how hot or cold a thing is. In the desert during the day, the sun is pouring energy down onto everything, and that energy wins easily. The sand heats up, the air heats up, you heat up. There's no contest. Trying to make ice at noon in the desert is like trying to fill a bucket with a hole in the bottom while 10 people pour water in from above. You've got no chance. But here's the thing that most people never think about. That race between gaining heat and losing heat doesn't stop at night. The sun goes down, and suddenly the biggest source of heat in the whole system just switches off. And now the other side of the race, the losing heat side, gets to run without anything fighting it. That is the crack in the wall that the Persian engineers found. They couldn't beat the desert during the day, so they stopped trying. They waited for the sun to leave, and then they went to work. Now, to really get this, you need to know one strange and wonderful fact about the night sky. When you look up at a clear night sky, you're not just looking at darkness. You're looking at outer space, and outer space is cold, unbelievably cold. Close to the coldest anything can possibly be. And here's the part that feels almost like magic but is just physics. Anything warm that has a clear view of that open sky will actually throw its heat upward, out through the air, and off into space. It's called radiant cooling, and it's happening all the time, everywhere, to everything. It's why your car windshield gets frost on it on a clear morning even when the air temperature never dropped to freezing. The glass was staring straight up at the cold sky all night, quietly bleeding its heat away into space, until its own surface dropped below freezing all on its own. The air around it was warmer. The ground beside it was warmer, but that one surface, pointed at the open sky, got cold enough to freeze. And if you understand that one fact, you understand 90% of how the Persians made ice. They found a way to point water at the night sky and let space do the freezing for them. But it's not quite that simple, and the reasons it's not simple are exactly where the genius comes in. Because there are three enemies standing between that water dish and the cold of space, and the Persian engineers had to defeat all three, at night, with nothing but mud, straw, and careful thinking. Enemy number one is the ground. The desert sand soaks up an enormous amount of heat during the day, and at night it slowly leaks that heat back out. If you just set your dish of water on the warm sand, the ground would keep feeding heat into it from below faster than the sky could pull it out from above. You'd never win. Enemy number two is the air. Even on a cold desert night, the air still carries warmth, and if that air is moving, if there's any breeze at all, it'll brush across your water and keep dumping heat into it, wiping out all your progress. And enemy number three is the water itself, or rather, how much of it you use. A deep pool of water holds a huge amount of heat and takes forever to cool. A thin film of water holds almost none and can cool in a hurry. So already you can see the shape of the solution forming. You need to lift the water off the hot ground. You need to shield it from the moving air, and you need to keep it shallow. Nail those three things, and space will hand you ice for free. So here's what the Persians actually built, and this is where it stops being theory and becomes one of the great machines of the ancient world. They called it a yakshal, which simply means ice pit, and the shape of it is unforgettable. Picture a giant pointed dome of mud brick, sometimes the size of a small mountain, rising out of the flat desert like a beehive built by something enormous. Some of them still stand today, more than 2,000 years later, and if you drive through parts of Iran, you can still see them standing against the sky. These huge earthen cones that once made ice in a place where ice should be impossible. And underneath that dome, dug deep into the ground, is a massive pit. That's where the ice was stored. But the making of the ice happened out in the open, in shallow channels and pools, laid out in the shade on the north side of the structure, where a long, tall wall blocked the daytime sun completely. And every piece of that design is aimed at one target. Beat the 3 enemies. Win the night. Let's walk through the night, because the timing of this is everything. Late in the afternoon, workers would fill the shallow channels with water. Not deep pools, thin sheets of water, just a few fingers deep, because remember, shallow water cools fast. These channels sat in the deep shade of that tall wall, which had been built and positioned to block the low sun, so even the last heat of the day couldn't reach them. Then the sun set, and the real work began, except no human had to do it. As the sky went dark, those thin sheets of water started staring straight up into open space, and they began throwing their heat upward, radiating it away into the cold of the universe, exactly like that frosty windshield. The tall wall beside them didn't just block the sun during the day. At night, it also blocked the warm breeze from sliding across the water, defeating enemy number 2. The water was sitting in shallow channels with a shaded floor, cut off from the heat of the deep ground, weakening enemy number 1. And because the water was so shallow, it had almost no stored heat to lose, so it cooled with astonishing speed, beating enemy number 3. All 3 enemies handled at once, by the shape of the thing alone. And in the deepest, coldest hours before dawn, the surface of that water would drop below freezing, and a skin of ice would form across the top. Thin at first, like glass, then thicker. And now comes the second half of the trick, which is arguably even more impressive than the freezing. Because making a bit of ice on a cold night is one thing. Keeping it, in a country where the very next afternoon will hit 50 degrees, that's a completely different problem. Ice that melts by lunchtime is a party trick. Ice that lasts through the summer is a technology. This is what that giant mud dome was really for. Just before sunrise, while everything was still frozen, workers moved fast. They broke the fresh ice off the channels and carried it into the pit beneath the dome, stacking it deep underground, layer after layer, sometimes packing straw between the layers, because straw is a brilliant insulator, full of tiny pockets of trapped air that heat struggles to cross. And that mud brick dome above them was doing the heavy lifting. Its walls at the base were sometimes as thick as 2 meters of solid earth. Heat from the blazing day outside would try to crawl through all that mud to reach the ice. But earth that thick doesn't let heat pass easily or quickly. By the time any warmth fought its way through, the day was over and the cold night had returned to push it back. The dome shape mattered too. Any heat that did sneak in and warm the air inside would rise, funneling up toward the point of the cone. And many of these structures had a vent right at the very top to let that hot air escape, pulling it up and out and away from the precious ice below. Some had walls and pools of water around them to cool the air before it ever touched the dome. Every single feature had a job, and that's the real lesson hiding inside this whole story. Nobody sat down with a physics textbook and calculated the temperature of outer space. There were no equations, there were no thermometers for most of this history. What there was thousands of years of people living in a brutal climate and paying extremely close attention. Somebody noticed that water in a shallow shaded dish sometimes had ice on it in the morning. Somebody else noticed it happened more on clear nights than cloudy ones. Somebody noticed a breeze ruined it. Somebody noticed thin water froze and deep water didn't. And slowly, over generations, all those little noticings stacked up into a machine that could freeze water in a furnace. The Persians didn't get lucky. They watched, and they remembered, and they built what they learned into mud and brick until the knowledge was baked right into the shape of a building. There's a small detail in how they filled those channels that shows just how carefully this was thought through. The water used for freezing often wasn't just poured in at random. It was frequently brought in cold to begin with, carried through underground channels called qanats that ran for miles beneath the desert. Water that had never seen the sun and arrived already chilled from its long journey through the cool earth. Starting with colder water meant a shorter race to freezing, and a shorter race meant thicker ice by morning. So before the sky even began its work, the engineers had already given it a head start. Every stage was stacked on top of the one before it. Cold water in, shallow channels, deep shade, blocking walls, open sky above. By the time the night was over, the desert had been quietly outsmarted at 4 or 5 different steps at once, and the person who filled the channel at dusk may never have thought of themselves as an engineer at all. They were just doing what worked, the way their parents had shown them, the way it had always been done, and it's worth saying plainly how much labor and organization sat behind all of this, because that's a part people skip. These weren't accidents that happened by themselves. Someone owned the ice house. Someone employed the workers who filled the channels, and someone employed the workers who rushed the ice underground before dawn. There were rules about who got the ice and what it was worth. And in the heat of summer, that ice could be genuinely valuable, a luxury that marked out the wealthy and the powerful. Whole small economies grew up around these frozen domes. The ability to hand someone a cold drink in the middle of a killing summer was a kind of quiet power, and the people who controlled the ice houses held it. This wasn't a curiosity or a hobby. It was infrastructure, as real and as organized as a well or a granary, and it was treated with exactly that seriousness. And the cloudy night detail is worth pausing on, because it proves they truly understood what was happening, even without the words we use for it. On a clear night, the water has an open path straight up to cold space, and it freezes beautifully. But on a cloudy night, the clouds act like a lid. They catch the heat the water is trying to throw upward and bounce a good deal of it right back down. The water can't see space anymore, so it can't lose its heat, so it won't freeze. The Persian ice makers knew this. They knew a clear sky was their friend and a cloudy sky was wasted effort, and they planned their ice-making nights around it. They may not have known the word radiation, but they had absolutely worked out that a clear sky made ice, and a covered sky did not. That's not luck. That's understanding, arrived at the long way around, by watching. Think about what this actually meant for the people who lived with it. In the deep heat of summer, in a place where 50 degrees was a normal afternoon, a wealthy household or a whole town could have cold water. They could have chilled treats, they could keep food from spoiling for longer. In fact, the Persians made a frozen dessert, sweetened and flavored and served cold in the middle of a desert summer. And many people consider it a distant ancestor of the ice cream and sorbet we eat today. Imagine tasting something cold and sweet in a place where the afternoon could kill you. It must have felt like pure luxury, almost like a small miracle. And it wasn't a miracle. It was mud, straw, shade, shallow water, underground rivers, and a clear open sky. That's the entire ingredient list. No power, no chemicals, no cold machinery of any kind. Just a very deep understanding of how heat moves, built up drop by drop over centuries, and then frozen, quite literally, into the shape of a building. And here's the part that should genuinely stop you for a second. We spent the 20th century solving this exact problem with electricity. We built humming machines full of gas and copper that pump heat out of a box, and we plug them into a wall, and they roar away burning power to keep our food cold, dumping their waste heat out the back and warming up the world a little more each time. The Persians solved the same problem with a building that used no power at all and never broke down in any way that a bit of mud couldn't fix. And now, in a wonderful twist, modern engineers are going back to these ideas. Scientists have built special materials that do the exact same thing those water dishes did, throwing heat up into space through the sky, cooling things down in full daylight with no electricity at all. They call it radiative cooling, and they're publishing papers on it as cutting-edge technology. Except it isn't new. Someone worked out the heart of it more than 2,000 years ago, standing in the dark in a hot desert, holding a shallow dish of water, waiting for the sky to do its quiet work. And these weren't rare one-off wonders built by a single genius. That's the part that really lands once you understand the trick. Across the dry heart of Persia, in town after town, these ice domes went up and did their quiet work for century after century. They spread across the region and lasted deep into more recent history, some of them still being used within living memory, before electric refrigeration finally arrived and made them unnecessary. Think about that span of time, a technology that worked so reliably in such a punishing climate that it stayed in use for the better part of 2,000 years and only stopped because we found something more convenient, not something that worked better in principle. The design was essentially finished. There was very little left to improve. The people who built the first ones and the people who used the last ones were separated by dozens of generations, and yet they were all running the same beautiful machine, powered by nothing but the setting sun and the open sky. So the next time someone tells you that people in the ancient world were simple, that they didn't understand the world around them, remember the ice. Remember that in one of the hottest places a human being has ever lived, with no electricity and no machines and no science as we'd recognize it, the Persians found a way to reach up into the cold of outer space and pull down a piece of ice. They did it by being patient. They did it by watching. They did it by respecting the desert instead of fighting it, and learning its rules so well that they could bend one of the harshest climates on Earth into handing them the one thing it seemed least able to give: ice, in the desert, with nothing but mud and the night sky. So here's my question for you. If you were dropped into that world with everything you know today, but no tools and no power, do you think you could have figured this out? Or would you have stood there in the heat, absolutely certain that ice in the desert was impossible? Tell me in the comments. See you in the next one.